أعزائي طلبة عمارة وهيكلية الحاسب، السلام عليكم ورحمة الله. أولا أنا آسف على التأخير، تأخرت نتيجة عملية تحضير البرنامج، عملية دراسة البرنامج اللي بدنا نسجل عليه. اليوم آخر محاضرة أعطيتكم إياها كانت عن الداتا ترانسفير انستراكشنز. اليوم بدنا نستكمل الانستراكشن سيت بتاعت ال 8086 ونبدأ بالماثماتيك instructions. The mathematic instructions include addition, subtraction, multiplication, and division. Let us start with the addition instructions. You place the cursor on the add, for example, the first instruction, and control and place, and that will take you to the add instruction. The add instruction, it adds the source to the destination and stores the result in the destination. The source can be register, immediate, and the destination can be memory or register. The instruction will add the contents of the source and destination, as you will see here. For example, move AL with 5, the AL, then add AL with -3. So the contents of AL will be added, which is 5, will be added to -3. 5 plus -3 will equal to 2. As simple as that. Let's go back to the top of the page, and here again we have add with carry. Add with carry performs the same function as add, except that the contents of the carry flag will be added to the source and destination, and the result will be stored in the destination. If the result includes carry, that will be stored in the carry flag again for the next add carry instruction. This instruction is used for multiple addition, like if you like to say add from 1 to 10, 1 plus 2 plus 3 plus 4. If there is a carry that wouldn't be lost from the addition. So in here, let's try this. STC means store, set the carry flag. Set the carry flag. The carry flag will be set to 1 here. Move AL with 5. Add with carry AL and 1. What will be added? 5 plus 1 plus the carry flag, that will make 7. If there is a carry, it will be stored in the carry flag again. Again, let's go back. Increment is nothing but adding 1 to the contents of the destination. Move AL with 4, increment AL. AL has 4, when you increment it, it will be 5. ASCII adjust for addition. We know that in the ASCII code, the numbers from 0 to 9, the decimal numbers, are represented by 30 to 39. So when we want to add 2 plus, say, 4, in fact, inside the computer, it will be added as 32 plus 34, because 32 is the 2 and 34 is the 4. The addition will be, say, 66. But, in fact, we need the result to be 6. ASCII adjust for addition will convert the 66 to 6. This is annoying. Keep calm and don't show this in second. Let's go back to second group, which is subtraction. That will include subtract, subtract with borrow, negate, decrement, ASCII adjust for subtraction, decimal adjust for subtraction, and compare. I forgot something here. Decimal adjust for addition is the same as ASCII adjust for addition, except that the representation of decimal, the decimal number is represented by four binary digits, which is nibble. It will be the same if we add two decimal numbers, binary coded decimal numbers. The result will be added in hex, but we need to return them to what they are, to the decimal binary coded decimal numbers. The DAA will convert the result back to binary coded decimal format. Now the subtraction, let's see subtraction, it subtracts the source from the destination, and the result will be stored in the destination. As you see here, what are the source and destination? Can be register, memory register, and memory immediate. See the example, move AL with 5, we loaded the low byte of the accumulator by 5, and we subtract AL with 1. That means we subtract 1 from the contents of the AL, and the result will be AL equals 4. Again, we go back to the top, and we have this sub with borrow. That is equivalent to add with carry. As in carry we have carry, as in addition we have carry flag, carry. In subtraction we have to borrow from the carry flag. And in here, if we set the carry flag, which means load it with 1, move AL with 5, sub with borrow AL with 3. That means subtract 3 from 5. The result will be 5 minus 3 minus 1. And the result will be 1. Again, we go back to the top. Negate. Negate, it has only one operand, which is a register, and that will give the ones complement of the number. Negate AL, AL is loaded with 5, and that will give you minus 5. So negate, negate will give you the minus value of the contents of the register. Again, decrement. We don't need to explain that. In fact, decrement is to decrement the content of the register by 1. Here, move AL with 255. Decrement AL, that means AL will be 254. Again, we have ASCII adjust for subtraction, decimal adjust for subtraction, and that is the same function as ASCII adjust for addition and decimal adjust for addition. So no need to go over that. Let's have the compare instruction. Compare instruction is very much like the subtraction instruction. It subtracts the source from the destination. However, it doesn't return a value, but return the result to the 0 flag. If the result is 0, then the 0 flag will be set to 1 automatically. And if not, 0 flag will remain 0. And that is used, in fact, for comparison and for the decision making in the programs. That is to say, if the result is 0, do so and so. Okay. Third part is the multiplication instruction. Here we have two options. If we multiply a byte or multiply 2 bytes or well. If we multiply a byte with, say, any operand, any value, the result will be stored. If usually we multiply, say, here we move BL, say, with 4, multiply BL. That means multiply BL with the contents of AL. The mult instruction usually multiplies the contents of its operand with the contents of the low byte of the accumulator. The result will be stored in AX. Here, say, BL is 4, AL was loaded with 200, multiply BL, that makes 100 decimal stored in AX. This is unsigned multiplication. There is signed number multiplication. Which is IMAL, signed multiply algorithm. In here, also, we multiply the contents of the low byte of the accumulator with, say, BL, which is loaded by -4, and the multiplication will be, the result of the multiplication will be signed. So here -2 multiplied by -4, that AX will be loaded with 8. Again, if the multiplication is with AX rather than AL, the result will be stored in AX and DS. DX. IMAL, as we said here, seems that they don't have okay, here they are showing that we are, no, they don't have AX. I'm sorry about that. We don't have AX. But if the multiplication with AX, the result will be stored in AX and DX. ASCII adjust for multiplication is very much the same as ASCII adjust for addition. It converts the ASCII code, the ASCII numbers, the result of multiplying the ASCII numbers back to their value. Finally, we have the division. It is absolutely the opposite of multiplication. Here, when we multiplied AL with another operand. However, when we divide, because the result will be stored in AX, here we divide AX by the operand, and the result will be stored in AL. It is a reverse process of the multiplication. IMAL is the same as, IDIV is the same as IMAL. It is for signed numbers, and ASCII adjust for addition is the same as ASCII adjust for multiplication. And here we stop